Now, prove by induction that 4 to the power of n is greater than 30n for n is greater than or equal to 4. The caret here, 4 to the power of n, means that the caret means 4 to the power of. And n is a natural number. So step 1, we let n is equal to 4. We test that. We find that 4 to the power of 4. We check if it's greater than or equal to 4. 30 multiplied by 4. And indeed, 256 is greater than 120. So it's true for n is equal to 4. Step 2, the assumption. We assume that it's true for n is equal to k. So we're assuming that 4 to the power of k is greater than 30k. Again, be careful. We have to say that k is greater than or equal to 4. And the same as the n is greater than or equal to 4. The k has to be 2. Step 3, we have to prove that it's now that it's true for n is equal to k plus 1. So again, that means we're trying to prove that 4 to the power of k plus 1 is greater than or equal to 30 multiplied by k plus 1. A nice way to proceed now is we start with the assumption. Our assumption is that 4 to the power of k is greater than 30k. So I'm going to start with that. 4 to the power of k is greater than or equal to 30k. I meant greater than or equal to up here. Again, I'm going to write down that k is greater than or equal to 4 here. And then I work this here. I work this towards what I'm trying to prove. So how do I turn 4 to the power of k to be 4 to the power of k plus 1? Well, I multiply both sides by 4. I'm going to have 4 multiplied by 4 to the power of k. That's going to be greater than or equal to, again, by the assumption, 4 multiplied by 30k. So I've now converted this as I like. So it's now 4 to the power of k plus 1 is greater than 120k. Now I've done what I needed to do at this stage. I've got 4 to the power of k plus 1 is therefore greater than 30 by k plus 1, which is my assumption. The reason I can say this is that when k is greater than or equal to 4, obviously 120k is greater than 30k plus 1. It's like if I say to you that, k is greater than 10. Well, obviously, k is going to be greater than 5 as well. Okay, and that's what I'm doing down here. I'm saying that 4 to the power of k plus 1 is greater than 120k. And as 120k is greater than or equal to 30k plus 1, for k is greater than or equal to 4, obviously, 4 to the power of k plus 1 is greater than 30 by k plus 1. By step 4, we're going to say P4 is true. We're going to say if Pk is true, then Pk plus 1 is true. So by induction, Pn is true for n greater than or equal to 4, n an element of the natural numbers. Alright, let's have a look at one more example. Prove by induction that n factorial is greater than 2 to the power of n for n greater than 4. So let's move on to step 1. So step 1, we're going to show that it's true for n is equal to 5. So we're going to have 5 factorial is greater than 2 to the power of 5. And that is 5 factorial is 120, and that's greater than 2, 4, 8, 16, 32. So it's true for n is equal to 5. Step 2, we're going to assume that it's true for n is equal to k. N is equal to k, which means that k factorial is greater than 2 to the power of k. Again, for k greater than 4. Step 3, we're going to prove, I like to write to prove, that k plus 1 factorial is greater than 2, make that into a factorial, 2 to the power of k plus 1. Okay, as I said the last time, let's start with the assumption. The assumption is that, here, I'll do it in yellow maybe. This is our assumption here. k factorial is greater than 2 to the power of k. So the assumption is that k factorial is greater than 2 to the power of k. K is greater than 4. Okay, so I need to convert this k factorial to k plus 1 factorial. So what I do is to do this, I need to multiply this by the next one up by k plus 1. So k, so k plus 1 times k factorial, that's greater than k plus 1 by 2 to the power of k. This is k plus 1 factorial is greater than, I'm still dealing with the assumption now, and I've navigated, I've made my left hand side to be the same as what I'm trying to prove up here. That's what I'm trying to prove, and I've now got this on the left hand side. And what have I got on the right? I've got 2 to the power of k by k plus 1. Okay, now we've actually proved it, because 2 to the power of k by k plus 1 is greater than 2 to the power of k plus 1, because 2 to the power of k plus 1, this here is just equal to 2 to the power 2 multiplied by 2 to the power of k, and this here 2 is a lot less than k plus 1, because k plus 1 is well, k has to be greater than 4, so k plus 1 has to be greater than 5, and 5 is greater than 2. This thing I've just written here on the right is probably good for your logic thinking, but not absolutely essential, because we've actually proven it already. So we proved that k plus 1 factorial is greater than 2 to the power of k plus 1, and that's our proof. So you're going to say by so P5 is true, and then we're going to say if pk is true, then pk plus 1 is true. So by induction, Pn is true for n greater than for n, an element of the natural numbers. I hope that helped.